Okay, week 3 written assignment part 1. A couple of things about reading information from graphs of functions. Here is a primitively drawn graph of f of x, okay? And you can see that this has a couple of local extrema. A local maximum value, the top of a hill, a local minimum or local min value that's happening at the point 0, -1 if you believe my drawing. Okay, here's the first thing that tends to confuse people into my math lab homework. Okay, so look for a local maximum. Most people don't have too much trouble saying, oh yeah, that'll be this point here that's higher than anything around it, that's the local maximum. Just read the graph from left to right, so like you're going uphill to the top, down to the bottom, uphill indefinitely. So that's the top of a hill, that's a local max. But my math lab will say, where is the local max? And they don't want you to tell them the point, they don't want you to tell them the ordered pair, and they don't want you to tell them that the maximum value is 3. They want you to say where it happens, and where always means for my math lab, and generally in math, where in the domain. So in other words, x's. The where question is where on the x-axis or with respect to the domain. So you're going through successively larger values of x as you go from left to right, and where you hit the local maximum is at -2. So where means x. If they say what is the maximum value, what's the local maximum value at that point, then they're asking about y's. Here's a local minimum, but where does it occur? Not at -1, even though you go from 3 down to -1 in height, it's happening when x is 0. It happens at 0, and what is the value? -1. You get a local min of -1 when x equals 0 at that place. Okay. Where is f of x, this function, decreasing? And again, you know, people will get confused because they read the graph this way and go, well, it decreases here. No, you have to read from left to right. So you scan for increasing values of x, and you move along the curve like this, and then think about what happens to the outputs, to y. Increase, 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 and then decrease, 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 and then increase, 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 increase. So again, when they're saying where, they mean x's. Where does this thing decrease? Well, it decreases from here to here, which is from x equals -2 to x equals 0. And I want to answer this in interval notation and say it decreases on the interval from -2 to 0. This isn't an ordered pair, but an interval saying for all values of x between -2 and 0, and by convention we'll use the open interval. You know, so for the interior of that interval, as we move from left to right, the function's going downhill. That's where it's decreasing. Where is it increasing? Well, it increases all the way up to -2. So it increases on the interval from -infinity to -2, right? And on the interval from 0 to infinity. Make sense? Okay. Now let's look at the worksheet that you're filling out. Okay, written assignment 3. Okay, and the first thing you're going to notice about this worksheet is there are 11 pages. Some of them are just for reference. You don't have to fill them all out, but there's a lot of work to do here. And you should be able to move through it at a pretty rapid pace. This first part has like 3 pages and 6 graphs. And don't use a calculator, just do point plotting. We're going to try to use more sophisticated methods of graphing in this course than point plotting. So this is kind of your last hurrah, your last chance to do point plotting. The first function is f of x equals x. That's the easiest thing in the world to calculate, right? When x is 4, f of x is 4. And when you plot these points, you're going to get points like 4, 4, and points like -1, -1, and they're all going to line up. So you're going to get a graph like this. And of course, you want to generate the graph not just the points that you graph, but an entire pattern of a graph. And then you'll answer some questions about this basic graph. Domain of f, well, what all x values? And if you look at this and say it's not just what's listed in the table, but it's all the x values that would be anywhere along this curve, that's all real numbers. And you could use interval notation like negative infinity to infinity. But that big R, that double barred R, is kind of a nice shorthand we'll use for all real numbers. The range, similarly, you could find a point along that line that has any y coordinate at all, from the lowest negative to the highest positive, all real numbers. Where's f increasing? As you read from left to right, you could say this, or you could say everywhere. We'll actually use that as a convention for saying it increases on its entire domain. Where does it decrease? Well, as you go from left to right, you never go downhill, and we'll simply say nowhere. That's exactly how I'd like you to fill that out. Okay, so you're going to do that for several functions. Let's go find a trickier one. I think the one that bugs people the most is probably the reciprocal function. Here we go. F of x equals 1 over x. So 1 over negative 6 simplifies to negative 1/6, and 1 over negative 4 is negative 1/4. 1 over negative 1 is negative 1. And 1 over negative 1/4, the reciprocal of negative 1/4, is actually negative 4. How about 1 over 0? Can't divide by 0. Undefined. And I would just write undefined in the table. And then I'm going to get these outputs. Okay, so let me kind of quickly sketch this. I'm going to get a point here, and at negative 2, negative 1/2, and at negative, I didn't even have that one on my list, negative 4, comma, negative 1/4, negative 6, comma, negative 1/6. I also have negative 1/4, comma, negative 4, that's a point about here. And similarly, I'm going to have some points over here. If you think about it carefully, you'll see that there are two parts to this graph. They don't connect up because we said that the function is undefined for an input of 0. So that means that the vertical line at x equals 0 is not going to have a point. So this actually has two separate pieces. It's actually a hyperbola, is the type of curve this is. The domain of f, again, just kind of look at the graph and say, well, what x values? It's kind of like the shadow of the graph on the x-axis. What x coordinates could be on this graph? And it's basically everything except 0. A compact way to say this, which is perfectly okay, is to say all real numbers except 0. Okay? And you can continue here. You know, this is an interesting function. When you scan from left to right, you're actually decreasing, right? Just slowly decreasing and then quickly decreasing. It's decreasing from negative infinity up to 0, not including 0, and from 0 to infinity. But I wouldn't say it's decreasing everywhere because of that undefined point in the middle. So I would give it those two separate intervals and kind of say, well, it's decreasing everywhere except for at 0. It's not even included in the domain. Okay, so you're going to cruise through 6 functions and get sketches for these. These are going to be our basic toolkit functions. So you are, you're point plotting them now, but in the future we're going to want you to really kind of memorize and be familiar with these 6 functions, the identity function, the square function, the cube function, the absolute value function, the reciprocal function, and the square root function. And maybe I'm missing one. Okay, I'll see you in part 2.